All right, today we're going to be going over 8-7, solving systems of linear equations. So a couple of things that you need to know is the first definition you need to know is systems of linear equations. That's when two or more, that's basically just two or more linear equations. So for example, if you look at number 1, notice I have two linear equations. When you have more than one linear equation or two or more, that is called a system. A solution of the system is any ordered pair that is a solution of each equation in the system. So what does that really mean? What it means is I need to find a point, an x and a y value, that work for this linear equation and work for this linear equation. So I could do some guessing and checking. I could try 1, 1. I could try 1, 2. I could try 5, 6. But we could be here forever trying to figure out. Okay, so there's a couple of different ways that you can solve and find that ordered pair or that solution to the system, and we're going to do that today. So what we're going to do is we are going to graph each of these lines. So remember, when we're graphing the lines, you have to make sure it's in slope-intercept form first of all. So y is equal to x minus 7 is in slope-intercept form. Remember then, what you're looking for is your y-intercept, which is what? What's my y-intercept? 0, -7 as an ordered pair. And then my slope, remember, is the number in front of the x, which is what? Anybody, tell me. 1. And so we're going to write it as a fraction, so we're going to put it as 1 over 1. Okay? So then we're going to graph this. So you guys have a graph right next to yours. I'm going to switch to my graph paper. Remember, you graph your y-intercept first. What was my y-intercept again?
0, -7.
So put a mark at 0, -7. And then remember, from that point, you are going to rise and run. So since it's 1, 1, I'm going up 1 and over 1. You make your mark again, and you are going to draw your line. Okay, so it should look something like that. There's arrows on the end of it. You just can't see it. You make sure yours has arrows. Okay? All right, then you're going to graph the second line. So everyone have this done?
Yeah.
Okay, so go back. We're going to graph the second line. Again, you're going to make sure it's in slope-intercept form, which it is. I am going to find that y-intercept, which is what? What's my y-intercept?
0, 2.
0, 2. And then my slope, remember, is the number in front of the x, which is what? 4. And we're going to put it over 1, so we have a rise over run. And now we're going to graph that one. So when I graph that one, what is my y-intercept again?
0, 2.
So 0, 2 is right here. And then my slope is what?
4 over 1.
So I'm going to go up 4 and over 1. So again, then you are going to draw that line. Now, what you want to happen, and I'm going to have to move that, and I think you're not going to see it on my graph, but hopefully you see it on your graph. You're going to see an overlap of your points. Okay? The overlap, or where the two lines come together, is your solution. Okay, so who has that on their paper? Do you see where they overlap or come together?
Yeah.
What is that point?
-10, -3.
Okay, so, and I can't, my graph is not quite large enough, and I don't think if I go down it will be anyway. Maybe it will. Yep, I just needed to make my line longer. So this is the point when both of these lines are a little bit longer. See if I can do that. Okay, so if both of those lines are a little bit longer, it looks like they are meeting at, did you say -3?
Yeah.
-10? Mine are not meeting.
Over 3 down 10.
Oh, is that where your guys are meeting?
Yeah.
Okay, remember, for some reason my points aren't exact, and so I think that's my issue, and I don't know how to fix that in Smartboard. So when you do yours is going to be more exact. It sounds like everyone in the classroom is getting that -3, -3, -10. Okay? So that's your ordered pair that works. So if you think about that, if you look at the graph on your paper, those two lines where they intersect, wouldn't that point be on both lines? So wherever those two lines intersect, that is a solution for the system because that's a point that works for both lines or is on both lines. Does that make sense?
Yeah.
Okay, let's do another one, and hopefully the next one will graph a little bit better for me. Okay, so on this one right here, again, check to make sure your equations are in slope-intercept form. In this case, they are. So this one here, my y-intercept is what?
0, -4.
Good. 0, -4. And my slope,
-1. Over 1.
good, is -1 over 1. Okay, I'm going to graph that one. So again, what was my y-intercept?
0, -4.
Okay, so 0, -4. And then what is my slope?
-1 over 1.
Okay, so remember -1 for the rise, it's actually going down. +1, I'm going to the right, so it's looking like this. And to make a better line, you guys, if you continue to do your rise over run and get more points, you can actually create a better line when you go to graph. What it also does is if you think about this when you're trying to come up with that intersection, you have to have a good line or you're not going to get the right answer. Does that make sense? So if I were doing this and I'm saying I'm going down 1 over 1, just keep doing that. Down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. And then line your ruler up and you're going to get a much nicer line. Okay? Did everyone get that line drawn? I'm going to encourage you to use a straight edge. If you don't use the straight edge, you're not going to get accurate answers when you're doing the systems. Make sure you're extending this